Now coming to the last part of the atomic structure, we have already discussed how to write the electronic configuration and all these things. Here I am going to tell you how to write the electronic configuration of an element by using the nearest noble gas configuration. By using the nearest noble gas configuration, how will you write the electronic configuration of an element? Now you might be thinking, why to use the nearest noble gas configuration? Why should we use it? For example, generally it is used because it is the electronic configuration becomes shorter, it becomes smaller. Alright, basically it is used for the elements having the higher atomic number, like atomic number 80 or 85 or 90 or 100, this sort of atomic number, but higher atomic number where you have to write it down so many, 1s2, 2s2, 2p6, 3s2, 3p6, it becomes two lines electronic configurations. Instead of that, we can write according to the nearest inert gas configuration. It becomes easier. If you know the electronic configuration of the nearest inert gas configuration, then it becomes easier to write the electronic configuration of those particular element. Otherwise you can write it down 1s2, 2s2, 2p6, you can go on writing it down and count it accordingly and you can fill it up. Got it? But when you write according to the nearest noble gas, then it becomes easy. And one more thing, in exam also, it is either the question is given according to the nearest noble gas configuration, or you may be asked to write according to the nearest noble gas configuration. At that time you have to write. There is no other option for you. So hence you have to learn it. So here certain things you have to, I'll tell you a trick by which you can remember it, the nearest noble gas configuration. I'll tell you a trick. First, what you need to know is that you need to know the, what you can say, the inert gas serially. Alright, according to the periodic table in the decreasing, what you can say, order. That is from the first period to the 7th period. You should know it. Got it? In the decreasing. That is the decreasing order, I should say. Or in the increasing order of atomic number, I should say. First you must know. Alright, see, I am writing it out. That is fluorine, chlorine, bromine, inert gas. No, sorry, I'm very sorry. I am writing the noble, that is halogens. Sorry, that is helium, neon, argon, krypton, xenon, radon. Alright, so first you wrote it down serially. That is the inert gas. Now what you do is that you write the period to which it belongs. It belongs to first period, it belongs to second, this third, fourth, fifth and sixth. Seventh we do not know. Alright, it is still not established. We can say that. Now next is, what you find is that you need to write, that is which block it belongs to. You know that. That is the atomic number of helium is 2. Alright, atomic number. So what you do is that first you write the atomic number. Alright. Now how to remember it? What you do is that you write the magic number. You might have studied in the lower classes in class 10. Magic number. Magic number means what? Magic number means that is nothing but 2, 8, 8, 18, 18, 32. This is a magic number. 2, 8, 8, 18, 18, 32. What I said? 2, 8, 8, 18, 18, 30. This is magic number. What is this magic number? Is it a magic? No. It is nothing but the number of elements in a given period. Number of elements in a given period. The first period consists 2 elements, then second 8, then fourth is 18, then fifth is 18, and sixth is 32, and seventh is incomplete. We know it. You consider this as the frequency. Alright, you take this as a frequency. This magic number which I have written, you take it as a frequency. Fine. Okay. Now, why I am taking this particular one? Why did I take this as a frequency? Because I need to know the atomic number of this particular inert gases. What are the atomic number of this inert gases? Now, you may say, sir, helium is 2, neon is 10, argon is 18. Then after that, you might not be knowing. Isn't it? So, how to remember the atomic number? For that reason, I am finding it out. This is a trick I am saying. So, first you write the magic number. Alright, you understood? First you write the magic number. You have written the magic number 288, 18, 18, 32. You have to remember this. Alright. Now this I took it as frequency. Now in maths you have studied cumulative frequency. First is 2, the second is 2 plus 8, 10. Then 10 plus 8, 18. 18 plus 18, 36. 36 plus 18 is 54. 54 plus 32 is nothing but 86. 4 plus 2, 6. 5 plus 3, 8. So this particular one corresponds to the atomic number 2, 10, 18, 36, 54, 86. Got it? How to remember the atomic number? In this way. First you write the magic number, that you consider as a frequency. Then you find a cumulative frequency, the one which you found it out, that is nothing but the atomic number of this inert gases. So one problem is over. You came to know the atomic number, because you have to know the atomic number of the inert gases. Fine. You know the number of, what you can say, the number of periods. This is the first period, the second period, the third period, fourth period. In this way you came to know. Now, when you write the electronic configuration of helium, what is that electronic configuration? It will be 1s2. So it is 1s. And rest all the inert gases belongs to p block, because if you write electronic configuration of neon, neon is what? 10. 10 means 1s2, 2s2, 2p6, isn't it? 1s2, 2s2, 2p6, 6, 4, 6 plus 4 is 10. So all other elements, listen carefully, all other neon, argon, krypton, xenon, radon, all ends in p block, means the last electron enters into the p subshell. All these belongs to p block, means the last electron, see here, the last electron, p6, the last electron is entering which subshell? P subshell. So hence what I write here, p, 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 p and p. I wrote, because last, you can write it and see it also. If you want to check, you can check it also. That except helium, all other elements, the last electrons enters into the p subshell. You can write it and see. Alright, fine. Now, you know that in as inert gas, the outermost shell is fully filled. It is fully filled. Fine. So that means helium, one shell is there. What is that? S subshell, which is fully filled. That means S2. Fully filled. Now, neon, that is fully filled. 6, 6, 6, 6, 6. Fully filled, na? The outermost shell, as well as if the subshell is fully filled, then the shell will be fully filled. Definitely. So here the subshell is fully filled. So shell will be fully filled. Definitely. Clear? Because inside the what you can say shell, we are having the subshell. So definitely the subshell is filled. The shell has to be fully filled. No doubt about it. Because number of electrons in the subshell, number of subshells, if you add it up, you will get the number of electrons in a shell. You can see it. Alright? Number of electrons in a subshell. I can tell you now only. For example, you know the first period consists of how many subshell? 1. S subshell. What is the capacity of S subshell? Maximum 2 electrons. What is the capacity of the first shell? 2 electrons. Now, second shell consists of how many subshell? S as well as P. What is the maximum capacity of S subshell? 2. What is the maximum capacity of P subshell? 6. So 6 plus 2 is how much? 8. So hence, what is the maximum number of electrons in the second shell? 8 electrons. In this way we do it. Alright? In third shell, apart from SP, we are also having D subshell. S subshell is maximum 2, P subshell maximum 6, D subshell maximum 10. Alright, P subshell is 6. So 10 plus 6, 16 plus 2, 18. S, P, D. 10 plus 6 plus 2. So how much you got? 18. What is the maximum capacity of the third shell? 18 only. In this way, we can say that each shell consists of number of subshells. So if you add the electrons in the subshell, you will get the number of electrons in a shell. That also proves that a shell consists of the subshell. Again, the subshell consists of orbitals. You add it and see the number of orbitals, you will be getting it the same as that of the subshell. So all this you need to understand it. You need to study. Then you will find it's very interesting. These things are. So hence you understood this particular one. First you write the element serially. Then you write the period 1, 2, 3, 4, 5, 6 serially. Then you write the atomic number. How did I got the atomic number? You know that. I have written it. Then after that, you know helium belongs to S subshell. The last electrons enters in the S subshell. And all other elements, it belongs to P subshell. It is complete, so P6. I have written it. Now, what I said you? To write the electronic configuration of an element according to the nearest noble gas, nearest inert gas, you must know the electronic configuration of the outermost shell or the outermost subshell of the inert gas. I got it. I got it. The outermost subshell, the electronic configuration of the outermost subshell of the inert gas. I got it. I got the atomic number also. Now you can write it down. The electron, what you can say, the atomic number of any element, you can take it and you can write it down, the electronic configuration of that particular element. Okay. Now let me just give you some examples. Let me just give you some examples so that it will be easy for you to understand that how we will be using this particular one to write the electronic configuration. Okay. Let me take some examples where it is. Okay, fine. So here let me take that is the element that is your nothing but what will I take? That is yttrium. That is atomic number is 39. Atomic number is 39. Fine. Now, which is the nearest inert gas? Krypton. Alright. So how you write it down? First you write it down in this way. Krypton 36. Now krypton ends in what? 4p6. Krypton ends in 4p6. Now you know always that much idea you have. You have read it periodic table in the class 10. That the inert gas is the outer, what you can say, sorry, the last group in a periodic table. The 18th group in the periodic table, inert gases, isn't it? We are having group 1, 2, 3, 4, 5, 6. In this way, the last group is your inert gas. Because a particular period ends in inert gas, isn't it? In the noble gas, the last, what you can say, group. Then after that what happens? Group 1 starts. That means after that what will happen? S block starts. But it's after 4p6 what you are having? 5s. You know that? Snake rule, you have studied. After 4p it is 5s. So krypton 36. So krypton 36, what is the what you can say outermost configuration? It is 4p6. So 4p6 means after that what I am going to start? 5s2. The 36 plus 2 is 38. One more is there. That is 39. So hence after 5s it is what? 4d. So 4d1. In this way, this is electronic configuration. Is it clear? First I wrote this 39. Okay. Now I see that 39 means I have to write according to nearest noble gas. What is the nearest noble gas? Krypton 36. So I wrote krypton 36. Krypton 36 ends in what? 4p6. So after 4p what it comes? 5s. I have seen in the snake rule. 5s will have maximum how many? 2. 5s2. So 36 plus 2 is 39. 38. I want 39. So one more. After 5s what it comes? 4d. So 41. Finished. Done in this way. Now here also I will tell you a trick. How to remember what you can say this particular one. See here. Look. That is here. Helium, neon, argon, krypton, xenon, and this is radon. 6. You see here. Helium, neon, argon, krypton, xenon, radon. In this way, serially. 6. You can see. Alright. First, second, third, fourth, fifth, and sixth. 1s2, 2p6. Second, no, this is second. 2p6. Then it will be what? 3p6. Fourth, 4p6. 5. 5p6. This is your 6p6. Alright, 6p6, you got it. Clear? Understood? 1s2, this is the first one. 1s2, the second one. 2p6, 3p6, 4p6, 5p6, 6p6. In your finger it is there. In your fingertip, keep it. Now this atomic number is 2, then it is 10, then it is 18, then it is 36, then it is 54, and this is your 86. Done. In this way, once or twice you practice it, you will be seeing that it will be in your fingertips. And in your fingertips you can remember it. Helium, neon, argon, krypton, xenon, radon. 1, 2, 3, 4, 5, 6. 1s2, 2p6, 3p6, 4p6, 5p6, 6p6. 2, 10, 18, 36, 54, 86. Done. In this way you can remember it. No problem. Alright. So in this way you can write the electronic configuration of an element. Now, that is one more, let me take it. That is your platinum 78. PT 78. So 78 means which one? You cannot take radon 86 and go back. No. You will have to take from xenon. Xc, what is that? 54. Fine. So Xc ends in 5p6. How it is see here? This is not there. 1, 2, 3, 4, 5, 6. Isn't it? Helium, neon, argon, krypton, xenon. Helium, neon, argon, krypton, xenon. This is your fifth. So 5p6 in this way. Remember it. So it is 5p6. So 5p after that what is that? 6s2. Alright? 6s. After 6s what will have? 4f. 4f is going to come. So hence it will be 6s2. 4f is having maximum 14. So see here, 54 plus 2, 56, 56 plus 4, 60, 10, 70. We got 70. Now after 4f, what we will have? 5d. 5d is how much? 8. See here, 54 plus 2, 56, 56 plus 10, 66 plus 4, 70 and 8, 78. So you have got this particular configuration for platinum, we can say that. That is nothing but you got it in this way. In some book you will find it out that they have written in this way also. In this way I have written it serially. 4f, then 5d, then they have written 6s. You know why the reason is? Why they have written in this way? 4, 5, 6 serially. Why? Because this forms the outermost shell and easily you can calculate the valency. Easily you can calculate the valency. What is the valency? That is nothing but 2. Clear? So in certain books you will find it out that it is being written in this particular manner. It is being written. We can say in certain books you can find it out. It is being written in this particular manner. Alright, that's 54. It is 78. 54 plus 2, 56. 56 plus 10, 60. 60 the plus 4, that is nothing but you can say 64, and this is another 8. Alright, that is sorry, I am only counting now. 56 plus 4, 60, 10, 70 plus 8, 78. In this way you can calculate the electronic configuration, or you can write the electronic configuration according to the nearest noble gas, we can say that. Clear? According to the nearest noble gas, you can say. You can write it down. So this is how to write it down according to the nearest noble gas. I have said you, it is in front of you. I hope you have understood this particular thing, how to write it down. Okay, thank you.